Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your introduction, chemistry and properties of carbohydrate. So first of all, we are going to see the introduction part, then we are going to discuss about the chemistry of the saccharides. Okay, then we are going to discuss about the properties of the sugar. Okay, sorry, not sugar, it's here the term that I'm going to use is a sucrose. Okay, so first of all, we are discuss the basic part. Okay, then move to their chemistry and their properties. Okay, we all know that these carbohydrates are what? They are the sugars. Okay, so they have a different categories like monosaccharide, disaccharide, and polysaccharides. Then this sucrose, maltose, glucose, they are what? They are the part of the carbohydrate. Okay, so let's start today's lecture. Carbohydrates, sugars, and starches are the most widely distributed and abundant organic chemical on earth. Okay, if we talk about the most abundant organic chemical, then it is what? It is a carbohydrate, sugars, and starches. They are what? They are the most abundant form of organic chemical which are present on a earth. They have a central role in the metabolism of animals and plants. Okay, so they also have a role in metabolism of both, that is your either animals or either plants. Okay, they also serve as a basic food. Okay, like you see that in every food product, these carbohydrates are present either in any form, like either in the form of glucose, either in the form of starch, either in the form of sucrose. They are present in a basic food product, accounting for a large portion of total nutrient intake. Okay, it also cover a large portion in a total nutrient intake. They act as a sweetening agent, gel or paste forming and thickening agent, stabilizers, and also act as a precursor for aroma and coloring substances, which is generated within a food by a series of reaction during handling and processing. Okay, they also act as different sweetening agent, gel or paste forming agent, thickening agent, stabilizer, and they also precursor the aroma and the coloring substances which are generated by the food product by a different reaction which occur inside the food product. Now the next is your historically carbohydrate were brought to be hydrates of carbon. They are what? They are the hydrates of the carbon. Okay, they are made up of what? Carbon, hydrogen, and oxygen. Okay, they are what? They are the organic compounds. On the basis of their molecular formula CnH2O, CnH2O, 1N. Okay, so N can be 1, 2, 3, 4, and etc. More realistically, carbohydrates are now considered as a polyhydroxyaldehyde, polyhydroxyketones, or the substances that yield such component on acid hydrolysis. Okay, so now this carbohydrate are considered as a polyhydroxyaldehyde, polyhydroxyketone, even the substances which yield the compound, that is your acid, yield the compound during the acid hydrolysis. Okay, now the next is your chemistry of the saccharides. After the introduction part, the next topic is your chemistry of the saccharides. Now, what is the saccharide? First of all, we have to know that what is the saccharides. These saccharides are basically what? They are the simple sugar. Simple sugar, and they are made by a combination, they are prepared by the combination of sugars or polymerized sugar. Sugars or polymerized sugars. Okay. They like your monosaccharides, disaccharides, polysaccharides, they are what? They are the form of the saccharides. Now, saccharin is a Latin word for a sugar. That means that the saccharides are derived from a Latin word that is your saccharin. And the saccharin meaning is sugar. And the derived term saccharide is the basis of system of carbohydrate classification. Okay, so this saccharides are what? These saccharides are considered as a base for the base for the um sorry that base for the classification of the sugars. Not sugars, it's carbohydrate. Okay, that is disaccharide, monosaccharide, polysaccharide. Then we consider on the basis of the saccharide. The simplest sugar belong to the carbohydrate class is monosaccharide. That means that we cannot divide this monosaccharide. It is the smallest unit of the carbohydrate. That is your fructose and glucose. Okay, glucose and fructose are structural isomers, and the molecular formula is C6H12O6. They are what? This is a molecular formula for the saccharides. Molecular formula for the saccharides. This is, sorry, molecular formula for the glucose and the fructose. And they are what? They are the structural isomers of each other. Now the next is your the structural formula of glucose that contain a ring having a 6 atom. That is your C5O pyranos form an aldehyde group, aldose. However, the structural formula of the fructose ring, which contain 5 atoms, that is C4 and 1O, fructose form. It is the form of fructose. And ketone group E2S. Okay, so this the first one is your alpha glucose. Okay, here this is your ring. Now, in a ring, the first here it is H, hydrogen group, of OH group, then CH2OH, then H, here O, then H, OH, H, OH, here OH and H. This is a alpha glucose. Okay. Now, this is your fructose. In fructose, here CH2OH group are attached and here CH2OH group are attached. Okay. Now the next is your the formula of D-glucose and D-fructose using a simplified Fisher projection may also be represented as follows. So this is a way to represent the D-glucose by using a Fisher projection. So here it is your CHO, then H, OH, OH, H, H, OH, H, OH, then again CH2OH. Here, two molecule of CH2OH, then the double bond of O, then single bond of AOH, then in the alternate OH are attached with a single bond. This is your D-fructose and this is your D-glucose. Disaccharides are formed by the union of two monosaccharides. Okay, monosaccharides are considered as the smallest unit. Smallest unit. Okay, monosaccharide are considered as the smallest unit. And now when two monosaccharides are combined together, then it will form a disaccharides. Okay, and when these two monosaccharides are combined together to form a disaccharide, then in that case there is a loss of one molecule of water. This the example of the disaccharides are lactose, cellulose, maltose, and sucrose. And the molecular formula of the sucrose is what? It is C12H22O11. It is the what? It is the molecular formula for the sucrose. Sucrose is what? Sucrose is a disaccharide. Now, one question for you. Write down in a comment box which two unit of monosaccharide form a sucrose. Okay. In the last of the video, I will give the answer. But first of all, you have to write down the answer in a comment box. Now the next is the structural formula for sucrose which contain 2 units of monosaccharide. Now here the answer: monosaccharides 2 unit which form a sucrose, that is your 1 unit of glucose and 1 unit of fructose. Okay, and this 1 unit of glucose and 1 unit of fructose form a bond that is called a they join together with the atom that is your oxygen atom. Okay, and the linkage between them is your glycoside linkage from carbon number 1 of unit 1 to a OH group of the other unit, that is your fructose. Okay, it form a bond between the hydrogen atom of glucose and OH group of the next, that is your fructose. So this is a structure which represent the sucrose. This is a glucose, this is your fructose. Now they join together with the oxygen molecule. Now the next is your hydrolysis of sucrose yield D-glucose and D-fructose. Okay, when there is a hydrolysis of sucrose are done, then two monosaccharide that we get is a D-glucose and D-fructose, and this process is called a inversion, and the sugar mixture produced is known as a invert sugar. Okay, so this is called what? This sugar is called what? This is called a invert sugar, and the process is called a inversion, because although this sucrose itself rotate plain polarized light to the right, and the mixture invert this light by rotating to the left. Okay, see why it is called the invert sugar? Because this sucrose is what? Sucrose rotate the plain polarized light into the right side. Rotate the plain polarized light into the right side. But in case of the product that we form, that is your D-glucose and D-fructose, what they do? They rotate the plane polarized light into the left side. Okay, that's why it is called a invert sugar, and the process is called a inversion. Now the next is the carbohydrate class. That the next class of carbohydrate is a polysaccharide, which represent a compound in which the molecule contain many units of monosaccharides. Okay, in disaccharide there is a 2 units of monosaccharide, but in case of the polysaccharide there are many units of this monosaccharide which join together by a link that is called a glycosidic linkage. Now when there is a complete hydrolysis of polysaccharides are done, then it will convert it into a monosaccharide. Okay, complete hydrolysis of the saccharide, complete hydrolysis of the polysaccharide give a product that is called a monosaccharide. Now starch is considered as a most valuable form of the polysaccharide. The starch molecule, that is your amylose and amylopectin, they are contain around 250 to 1000 or even more glucose unit. Okay, That is per molecule joined together, although by a alpha linkage. That is the C. This is your amylose. Okay, here more than around 250 to 1000 unit of the glucose joined together, and then this amylose are formed. See, this is 1 unit of the glucose, again one, and so on. And the link between them is what? Alpha linkage or glycosidic linkage. Now the next is your monosaccharides. This is a representation of the monosaccharides. That is your D-galactose, D-ribose, and 2-deoxyribose. The first one is your D-galactose, then D-ribose, then 2-deoxy-D-ribose. Okay. Now the next is your disaccharides. This is your maltose, then cellulose, then this is your sucrose, then lactose. Okay. Now the next is your cellulose is a most abundant polysaccharide. Okay. The cellulose are considered as a most abundant form of the polysaccharide, and it is the fibrous component of a plant cell wall. That is, for example, cotton. Cellulose molecules are the chain of the molecules upon 14 thousands of the unit of glucose linked together, and the linkage between them is a beta linkage. Okay, when around 40,000 units of the D-glucose joined together by a beta linkage, then this cellulose are formed. So this is a representation of the cellulose, or poly 1,4 uh, O beta D glucopyranoside. These are the example of the cellulose. Okay, they are found, what they it is the most abundant form of the polysaccharide. Now the next is your properties of the sucrose. Before starting the properties of the sucrose, we divide it into a two parts. Okay, here we covered few properties of the sucrose. Then in the next lecture, the remaining properties of the sucrose will be completed. In commercial uses, the term sugar usually referred to as a sucrose. Okay, if we talk about at a commercial level, then in that case, sucrose are considered as a sugar. Sucrose is, we all know that it is what? It is a disaccharide which are made up of glucose and fructose, that naturally in every fruit and vegetable. Okay, and we all know that the sucrose are present in every vegetables and fruits, and it is also a major product of the photosynthesis, the process by which plant transform the energy of the sun into the food. This photosynthesis is what? In photosynthesis, plant transfer the energy of the sun into a food. They are basic. Okay, now during this process, sucrose is very important. Sugar occur in a greatest quantities in sugarcane and sugar beet, from which it is separated for a commercial use. Fully refined sugar, whether which is made from a cane or beet, it is a pure form of the sucrose, and consumer cannot tell from which of the two plant it is derived. Despite the identical product, the sugarcane and the sugar beet industry differ greatly in the methods of the production and organization. Each has its own distinctive history and geography. Now the next is your sucrose crystallizes from aqueous solution, that is monoclinic hemimorphic crystals, and the presence of the raffinose or dextrine impurities. If it is present in a quantity, then product long needle-like shape. Then it produces long needle-like shape. The melting point of the sucrose is about 188 degrees Celsius, which is rather indefined because it appears to depend upon the solvent used for the crystallization, and the density of the sucrose is around 1.5879 gram per centimeter cube, and the linear expansion of the coefficient, which is ranges from around 0.0282 to 0.050%, which is depend upon the axis. Characteristic infrared, that is called a IR absorption band, occur at 1010, 990, 940, 920, 870, 850 centimeter sharp, and 680 and 580 centimeter broad, and the specific heat of crystalline sucrose is around 450.98 joule per mole, and the temperature is 200 degrees Celsius. The dipole moment is around 2.8 into 29 centimeter, 8.38. Sucrose is readily soluble in water, and its solubility are increases when the temperature is rises. It is sparingly soluble in alcohol, but moderately soluble in organic solvents such as dimethyl formaldehyd, pyridine, and dimethyl sulfoxide. Okay, now the next is your an important properties of sucrose in solution is its polarization. It is well known that the sucrose in solution rotate a polarized light to the right in equal proportional to the quantity of the sucrose present. The great utility of this property is in the use of the saccharometer, an instrument which is directly reads the percentage of the sucrose present in sucrose bearing materials. Therefore, the sucrose is purchased and various stage of the manufacturing processes are monitored by the polarization measurement. Okay, so this is all about the today's lecture, that is your introduction, chemistry, and the properties of the carbohydrate. Basically, in when I start the properties, I told you that it is the half, but I said it by mistake. But here the properties of the sucrose are completed. Okay, it is not half. It is not made by made in two videos. It is only contain one videos, that is the introduction, chemistry, and the properties of the carbohydrate or properties of the sucrose. I hope you will understand. But if you have any query related to this topic, you can ask me in a comment box, or you can follow the ITLS Academy on different platform, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450, and visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.